Alright class, so the last mechanism in alkanes is the mechanism for the dehydration of alcohol. So dehydration of alcohol involving the elimination reaction. We will eliminate the H2O molecule from the alcohol. So the process of the elimination must be from the neighboring carbon. Okay, OH and H is removed from the neighboring carbon by using the Sazaf rule to predict the major and minor product. So step involving in the mechanism of the dehydration, the first step is the protonation of the alcohol group, OH group, hydroxy group, by using the concentrated sulfuric acid H2SO4. So H single bond OSO3H come from the H2SO4 molecule. So you need to expand the single bond H here for the acid. Why? Because you need to show the bond breaking between the O and H. So the lone pair of the oxygen on the alcohol attack the H. Why? Because oxygen in the alcohol is the nucleophilic side, electron rich, while the H from the acid is the electrophilic side. So yang kaya electron rich attack H. At the same time, the single bond between the H and oxygen will breaking. The single bond breaking towards oxygen because the oxygen is more electronegative atom. So the product form, the single bond is formed between the O and H here. So single bond di sini terbentuk due to the lone pair on oxygen form a new single bond. So we produce the protonated alcohol with the positively charged on the oxygen atom. And the side product is HSO4 minus charge. Why? Because H plus is donated to the oxygen. Produce HSO4 minus. First step. So the next step, second step, the product formed from the first step, which is the protonated alcohol, continue in the second step. So this protonated alcohol with loss of the water. Dia akan kehilangan air. Which part of the water? This part, H2O. So the single bond between the carbon and oxygen need to break to form the H2O molecule. Kita kena putuskan ikatan single bond di sinilah untuk menghasilkan H2O. Nak remove water, nak loss of the water molecule. After the bond breaking between the C and O, so the C will form the positive ion, which is the formation of the carbocation. So untuk second step, as usual, macam kita buat mechanism hydration and hydrohalogenation, mesti consider sama ada rearrangement can occur ataupun tidak. Kalau dia form less stable and it able to form more stable, so pelajar kena show the rearrangement in the second step of the mechanism. Okay, next, the carbocation form in the second step akan proceed in the third step, which is in the third step, remove the proton from the neighboring carbon. So kita akan buang hidrogen daripada carbon yang bersebelahan. Okay, di mana HSO4 minus, ni HSO4 minus from the first step akan digunakan dalam third step ni. HSO4 minus charge. So O minus akan attack the H from the neighboring carbon. At the same time, the CH bond breaking. The single bond between the C and H will form the double bond between the carbon and carbon plus. So produce alkene compound. And O minus attack H to form H2SO4. So H2SO4 akan terhasil semula. Dia akan repeat the first step. Sampailah the reaction completely reacted to form the final product. Okay, dia like repeating mechanism. Alright, based on the provided equation from the previous slide, so we will start the step number 1 by using the reactant, which is 2-methyl-2-propanol and the concentrated acid. So student should draw the expanded structure for the HO bond to show the bond breaking between the H and oxygen. So what happened in this first step? So look at the structure. Which structure is the electron rich? Oxygen here. Dia ada banyak electron around it. So one of the lone pair on oxygen act as the nucleophile, attack the electrophilic site, which is hydrogen. So kita akan buat arrow. The lone pair electron from oxygen attack hydrogen. At the same time, the H bond towards oxygen akan breaking by using the heterolytic cleavage. So bond breaking towards oxygen because oxygen more electronegative atom. So more ability to attract the bonded electron to itself to produce. Okay, what happened? The lone pair on oxygen is used to form a new single bond between the O and H. So oxygen remain only one lone pair electron. So get the positively charged on oxygen. And what happened to the acid? Form the HSO4 minus anion. Okay, so the product formed in the first step is called as the protonated alcohol. So protonated alcohol will proceed in the second step, which is in the second step, process removing of water. So look at the structure. Which part is H2O part? This part, H2O. So H2O bonded to the carbon with the single bond. To remove the water, you need to breaking the C single bond here. Betul? So nak breaking this bond by using the heterolytic cleavage because oxygen is more electronegative than carbon. So you show the arrow from the single bond towards oxygen. Okay, so what happened? The bond breaking akan membentuk carbocation, iaitu C with the positively charged. Kenapa C positively charged? Because carbon di sini dah tak cukup ikatan dah. Ada 3 ikatan je. So dia akan dapat positive charge. Next, H2O remove. So H2O dah combine. So one of the single bond akan form another lone pair on oxygen. So kita akan remove the water molecule. Boleh? So dapatlah product in the second step is the carbocation. So look at the carbocation form. The carbocation form is the tertiary carbocation. Kalau tertiary carbocation form, so confirm lah, tak payah nak fikir dah. Dia boleh lakukan rearrangement ataupun tidak. Sebab dah memang the most stable carbocation. Terus proceed kepada third step. So the carbocation form in the second step, proceed in the third step. Copy paste structure tersebut. So dia akan remove hydrogen from the neighboring carbon. So this carbon plus contain 3 neighboring carbon. 1, 2, 3 neighboring carbon. Betul tak? So ketiga-tiga neighboring carbon for this carbocation are identical and symmetry, which is primary carbon, and primary carbon. So you need to consider only one product is formed during this removing of the primary hydrogen. Boleh? Kita akan remove hydrogen from the primary carbon, which is primary hydrogen. So by using the HSO4 minus and ion produced in the first step to the third step here. So negative charge, which is the nucleophile, will attack the electrophile, iaitu H. Ada 1, 2, 3. Tak kisah mana-manalah H awak nak guna. Salah satu saja. So HSO4 minus in nucleophile attack one of the hydrogen primary. At the same time, the carbon single bond H breaking to form the carbon-carbon double bond. So dapatlah pembentukan carbon-carbon double bond between the first carbon and second carbon. Okay? Dan juga dapat semula dia punya side product kita iaitu H2SO4, which is the acid as catalyst. That's why catalyst ni sebenarnya kita perlukan sedikit je kuantiti dia sebab kita akan gunakan semula sulfuric acid as the catalyst to repeat the step number 1 until the complete reaction. Okay? Alright, we proceed with the next example. Okay, example, this alcohol 2-butanol undergoes dehydration using the concentrated sulfuric acid and heat. Okay, how many product is produced? Yang ni madam dah ajar dah masa minggu ke-7. Kita akan remove OH from the second carbon, betul tak? And H from the primary carbon, primary hydrogen remove. So first product kita. Ataupun kita boleh remove H from the secondary carbon, iaitu secondary hydrogen. So dah akan dapat different product. Sebab kita punya konsep removing of the H and OH mesti daripada neighboring carbon. Ni Miriam dah terangkan masa awal-awal kita masuk topik 5. From the neighboring carbon. So that's why lah we produce two types of product. So removing the secondary hydrogen, formation of the carbon-carbon double bond between carbon number 2 and carbon number 3, or formation of the second product, iaitu removing of the primary hydrogen. So dia akan produce carbon-carbon double bond between carbon number 1 and carbon number 2. So kita akan dapat dua produk yang berbeza, 2-butene and 1-butene. Which is the 2-butene is the major product using the Set-Zeff rule. Okay, Set-Zeff rule ingat lagi. More alkyl group bonded to the carbon-carbon double bond. So 2-butene dia ada di-substituted alkene. Okay, ada dua alkyl group bonded to it. Ni, 1, 2 alkyl group. Manakala 1-butene only one alkyl group bonded to it, iaitu mono substituted alkene. That's why lah 1-butene is the minor product for this case. Alright, Set-Zeff rule balik Okay, concept removing of the H and OH from the neighboring carbon, and the major product determined by using the Set-Zeff rule. So how to show the mechanism for this formation of the product major and minor? So maksudnya ada dua produk major minor. So macam nak tentukan dalam mekanisme, kita tengok Step pertama. So the alcohol will react with the sulfuric acid. So what happened? The lone pair on oxygen attack the H. At the same time, single bond akan breaking towards oxygen. Boleh? Same process. So oxygen akan dapat kedua-dua elektron to form the HSO4-, manakala O using a lone pair to form a new single bond with the hydrogen to form the protonated alcohol. Kita boleh condensekan kat sini. Okay, dan juga HSO4-. So step number 2, the product formed from the first step, which is the protonated alcohol, proceed in the second step, which is second step, remove the water molecule. Which part of the water molecule? This part. Nampak tak? H2, H2O. So what happened? Kita kena breaking the single bond between the carbon and oxygen. So breaking the bond mesti konsep heterolytic cleavage, di mana oxygen is more electronegative atom. That's why lah the arrow breaking from the bonding towards oxygen. So what is the product form? C dah hilang ikatan, dia akan form positive carbocation. C with the positive charge. Carbocation is formed and H2O is formed. So check the carbocation form. The carbocation form is the secondary carbocation. Boleh tak dia bentuk tertiary carbocation bila buat arrangement? Cuba cek sebelah dia. Karbon kedua, karbon pertama. Karbon pertama primary carbon, karbon kedua secondary carbon awak. That mean dia takkan buat rearrangement lah. Sebab tak ada tertiary carbon di sebelahnya. So takkan buat rearrangement. Rearrangement berlaku bila ada more stable carbocation can be formed from the neighboring carbon. So kita akan stop pada secondary carbocation at step number 2. No need to show the rearrangement sebab memang tak berlaku lah rearrangement dekat sini. So the secondary carbocation we proceed with the third step. Ni. So secondary carbocation produced in the second step akan proceed in the third step, which is kita akan remove pula H from the neighboring carbon. So step 3 ni akan ada 2 lah. Step dia kenapa ada 2? Sebab kita nak remove 2 type of the hydrogen, secondary hydrogen and primary hydrogen. So kalau kita gunakan HSO4- attack H from the secondary carbon, which is the secondary hydrogen remove. So the bond breaking pergi bentuk akan form pi bond ataupun double bond between the carbon number 2 and carbon number 3. Okay, remove the secondary hydrogen. So dia akan form carbon number 2 and carbon number 3. Carbon-carbon double bond, which is 2-butene is formed. Ada satu lagi kebarangkalian lain, iaitu kita remove hydrogen from the primary carbon. So, kalau kita remove primary hydrogen from the primary carbon, so kita akan tunjuk juga sama je step dia. Using the HSO4-, HSO4- will attack the H from the primary carbon. At the same time, the single bond will form the pi bond between carbon number 1 and carbon number 2. So, remove primary hydrogen. So, dia akan form carbon-carbon double bond between carbon number 1 and carbon number 2, which is 1-butene is produced and the side product is the H2SO4. Okay, so nampak tak? Formation of the 2-butene and 1-butene in the third step. So, both of the product major and minor is produced in this step. Kenapa yang atas ni major? Sebab dia remove secondary hydrogen, weakest bond. Yang bawah ni minor product sebab dia remove primary hydrogen, stronger compared to secondary hydrogen. Okey, tapi kalau orang gunakan Set-Zeff rule pun boleh juga, sama je konsep dia. Set-Zeff rule pun kita akan tengok major product kita 2-butene sebab dia ada 2 alkyl group bonded to the carbon-carbon double bond, iaitu disubstituted alkene. Manakala 1-butene awal only 1 alkyl group, iaitu mono-substituted alkene. Boleh? Itu adalah contoh melibatkan example involving the formation of the major and minor product.